What I want to do is prove to you that I know this combination without revealing the combination to you. And what you could do is you could write a little note, a secret that I definitely wouldn't know. Fold it up, stick it in here. And then if I know the combination, I should be able to open it and tell you what you wrote. All right. There we go. All right. So my dog is named Doug. Did you figure out what the combination was?
No.
So nowhere in this interaction did you see any information that you didn't already know. And yet I convinced you that I know the combination, right?
Yeah.
Hi, my name is Amit Sahai, and I'm a professor of computer science at the UCLA Samueli School of Engineering. Today I've been asked to explain zero-knowledge proofs in 5 levels of increasing complexity. A zero-knowledge proof is a way for a prover to convince a verifier that some statement is true, and yet reveal no additional information beyond the fact that the statement is true. Zero-knowledge proofs are being used in blockchains and cryptocurrencies, so cryptographers are excited about zero-knowledge because of its amazing mathematical properties, but also because of its incredible applicability to so many different scenarios. What's your favorite subject?
I'd say math. Some of these small problems can actually be really big and complicated. It's like a puzzle.
I love math for the same reason. Today I'm going to tell you about a thing called a zero-knowledge proof. So in a zero-knowledge proof, there are 2 people. There's a prover and a verifier. And I want to prove that something is true to you. But the weird thing is, I want to prove to you that it's true without telling you any reasons why. I remember when I first heard about it, I was like, wait, what? How could that possibly be, right?
Yeah.
So what do you see in this photo?
A lot of penguins.
Yeah. Hidden among all these penguins is a puffin. Do you want to try to look for it? Do you see where it is? I know where it is, but I don't want to tell you. Do you believe me? You're not sure to believe me, right?
Yeah.
But what if I could prove to you that I know where the puffin is without revealing to you where it is? Let me show you. I took that photo that we showed you and I put it behind this poster here. Why don't you go take a look through that hole?
I see the puffin.
So when you look at this board, we don't know where the photo was, right? Was the photo like with the corner here, in which case the puffin would be all the way at this side? Or was the photo with the corner here, in which case the puffin would be on the other side? So this is a really simple example of a zero-knowledge proof. I convinced you that I knew where the puffin was, but you didn't learn anything else.
Why do you study zero-knowledge proof?
When I first learned about them, I just thought they were so cool. But it turns out they're also really useful, not just for finding like puffins. If you just type in your password and a hacker hacks into the computer, they can just get your password, right?
Yeah.
What if instead we could somehow use a zero-knowledge proof to log in? You would just be able to prove that, hey, I'm Chelsea, without revealing anything to them. If you could do that, then it would be amazing, right?
Yeah.
Because then even if the hacker hacked into the computer, he wouldn't learn anything, because even the computer doesn't learn anything. So Chelsea, in your own words, what is a zero-knowledge proof?
Zero-knowledge proof is proof to a statement. You don't show them why or what. You just show them a tiny segment or just do some sort of weird magic trick. That's not really a magic trick. And they will be convinced and you didn't show them why or anything like that.
So have you ever heard the term zero-knowledge proof before?
I have not,
You have not, right? It's a way for a prover to convince a verifier that something is true without revealing anything about why it's true, which sounds totally bizarre, right? Like, how can that possibly be? What I want to do is prove to you that I know this combination without revealing the combination to you. And what you could do is you could write a little note, a secret that I definitely wouldn't know. Fold it up, stick it in here. And then if I know the combination, I should be able to open it and tell you what you wrote. All right. There we go. All right. So my dog is named Doug. Did you figure out what the combination was?
No.
So nowhere in this interaction did you see any information that you didn't already know. And yet I convinced you that I know the combination, right?
Yeah. So what's the exact purpose of a zero knowledge proof? Is it like proving something but without giving enough information that could endanger whatever it is that you're proving?
So you're asking, like, why shouldn't I just share my secrets with somebody? People don't trust each other. And if I was able to prove that I've done something correctly to someone without having to reveal my secrets, then that person would trust me more.
How does this relate to computer technology? Like, do you type it into a computer and somebody else receives it, or is it an in-person interaction?
Suppose you wanted to exchange messages with someone that you knew. What would you guys do? You'd probably first get together and like figure out some secret code, right? And then like write messages to each other in that code. But what if you've never met the person before? What if you want to exchange secret messages with me and we've never met each other before? How could we possibly do that?
I have no idea.
It sounds impossible, right?
It does.
But it's not. We wouldn't use like a physical lock or a physical box. We would instead use mathematics to do these kinds of things. You could take a message and encrypt it using mathematics. And then I could prove to you that I know the key. I could open it up and send it back to you. That way I would be proving to you that I know the mathematical key to the mathematical lockbox. So based on what we've discussed today, in your own words, what is a zero knowledge proof?
It's like if you have this really important secret that you want somebody to know about, but you don't want to tell them everything. You can use a zero knowledge proof to prove to them that secret, but not give away all of it.
What are you studying?
I'm a first-year computer science student at USC Viterbi. I'm interested in all things like data and internet and blockchain and cryptocurrency.
Have you ever heard of zero knowledge proofs?
Only in passing.
So actually in the blockchain space is one of the spaces where we are seeing zero knowledge proofs being implemented. And I think it's just the beginning. Let's talk about zero knowledge proofs. At its core, a zero knowledge proof is an interaction between two people. Then I should be able to convince you that some statement is true, but you won't have any idea why it's true.
Well, I understand that it's true because the operations performed in the proof are like of a certain they have like certain attributes that would make them true.
What you're basically asking me is, wait, what? Right? So this is what makes zero knowledge proof so fascinating and so counterintuitive. And I think the best way I can explain it to you is by means of an example. But before we do that, I have to decide what I'm going to prove to you with a zero knowledge proof.
Sounds good.
And the way we're going to approach this is through something called NP completeness. What an NP complete problem is, it's a problem that's really hard to solve, but if you can solve it, you can solve any problem that's in the class NP. And that includes a vast number of problems. And what we're going to do is we're going to use an NP-complete problem to actually prove an incredible variety of statements through a zero-knowledge proof. And the specific NP-complete problem that we're going to be looking at is called map 3 coloring. Okay, so here we have a map, okay? And these are a bunch of countries. And we've arranged them so that no countries that have the same color share a border. That's what makes a map like this validly colored. And now you might think, well, why should we care? It turns out that whether or not a map can be 3-colored in this way is an example of an NP-complete problem. And it turns out that maybe what you really want to do is you want to give a zero-knowledge proof that you have at least 0.3 bitcoins, right? That would be cool.
Yeah.
Without revealing what the address is of your account. It turns out I can take that statement that I have at least 0.2 bitcoins and convert it into a map of countries. And that map of countries will be 3-colorable like this only if you have at least 0.2 bitcoins.
How would we turn something like this into a zero knowledge proof?
Of course, the first step is we have to erase all the colors. What I've done is I've put a color inside each of these envelopes. Now, how do you know that it's a valid coloring? You don't, right? You have to pick any 2 neighboring countries. You can pick them however you like at random.
Can I get these 2?
These 2. All right, sounds good, right? Here we have green right? And over here, we have blue, okay? And as you can see, they're two different colors, right? So you have a little bit of confidence, right? That I have managed to color this correctly, but not that much confidence because I've only shown you 2 of the countries,
Yeah.
right? So now, of course, one way to get more confidence is to open up more of them for you, but that would be revealing information to you. I don't want to do that. So instead, I'm going to ask you to please turn around. And now let's change up these colors. Can you pick 2 countries at random and we'll reveal to you the colors again.
I'll pick this one and this one.
Nice. And that's smart of you to check with the same, one of the ones you already had, right? But as you'll see, now it's not green, it's blue. And this one, on the other hand, is green. Okay? The colors I showed you last time don't work with these new colors, right? This wouldn't have worked before.
Yeah, because of this one, right?
Exactly, right? But it works for this coloring that I'm showing you right now. So what we've done is we've made it impossible for you to put the pieces together. And if you do this, let's say 1,000 times, and if I correctly showed you different colors each 1,000 times, you'd be really convinced. And that's it. That's the entire zero-knowledge proof.
Oh, okay. So is it like, there's no like actual like explicit like step 1, step 2, step
No.
3. It's just like a probabilistic proof.
Yeah, in actual implementations, we wouldn't use envelopes, we would use encryption, right? But it's really, this is the protocol.
So what are the broader implications of like zero knowledge proofs? Are they supposed to be like more practical for like implementation end, or are they supposed to like structurally prove something?
It's not about making something more efficient. It's about doing things that we just didn't know how to do before. I can actually prove to you without revealing to you any of my secrets that I use to behave honestly, right? I could prove to you that I signed some encrypted document correctly, right? Without revealing to you what that secret document was. That ability to change the game, like really just change what we can do, is what zero knowledge brings to the table.
Where do you think we could build like more trust using like zero knowledge proofs and like its implementations?
One great example is like in elections. If you could prove that an election was correctly conducted, that every vote was counted, and it all added up to one person winning with a particular total in zero knowledge, then you don't have to give up the actual votes of any person, and yet everyone could see that, hey, yeah, it was done correctly.